Alright, we're going to show you the new heated, chilled syringe printing head it's capable of sub-zero freezing temperatures up to 70 degrees Celsius. It operates with Peltier junction devices on these heatsink blocks that are water cooled. So that's what this tubing configuration is for here. Using a standard water pump. In this case we're using just a 5-gallon bucket, but whatever reservoir you have handy is going to work. When you're installing this on the machine, it's going to load just like a normal print head into the Gibbs. If you're using a System 30 or an engine, you want to use your leftmost position. One small modification you want to make is because the Peltier devices draw over 6 amps, you want to change out one of the fuses in your yoke. So you're going to remove the top circuit board, take the screws out, remove this.
Power down.
Power down, turn the machine off first. Always a good idea. As you can see, I'm just going to take some small pointed pliers, pull the old fuse, and place the new one in place. If I can get it straight. So that's in place. And this, as you can see, this board is just like the lower end connector. Install that there, and this is going to bring auxiliary power to the end of the refrigeration device. So you see this uses standard 30cc BD syringe. Circulating air off of it and gives a little insulation. It's just going to snap into place, and with a little viewing window so you can see the contents. Alright, so before you turn it on, you want to plug in your water supply. Of course, this can be from any source. We're using just a standard aquarium pump here to circulate water. Verifying the water is flowing. Okay, so if we come down here, let's try to cool it down. Oops, if I can get the mouse to work. And this will get very cold. You'll actually see, you might even see some frost developing on the back side of the syringe holder. Depending on the material you're using and how full your syringe is, the temperature in the center of your material, it's going to take about 10 to 15 minutes for it to conduct all the way through. And my test showed that I was about 5 degrees Celsius warmer in the center of the syringe with a thermocouple than the temperature reading right here. And that's simply because we're reading the temperature on the outside, not the inside of the syringe. So you can see it rapidly cooling down now. So now it's dropping below freezing here. Now let's just do the opposite, heat it back up for whatever purposes you may have to do so. Let's say you want to get something around body temperature there.
For the heating, do we need the water circulating, or it doesn't matter?
Yeah, you have to have water circulating. It works on a temperature differential. It says peltier device. It just goes in either direction. So you can see now it's heating up rapidly, so you can get some pretty rapid temperature changes. It's just going to take a while for the temperature to conduct to the center of your syringe, depending on the conductivity of your material. Alright, everything else about this is going to be just like our standard syringe dispensing heads, which Davo can tell you all about. As far as, loading, setting your pulses, your prime and unprime. This could also be used with our pinch valve accessory or UV curing lights if you need ultraviolet curing. And that would attach by the same method using the standoffs on the bottom, and there are some holes in the bottom of your heat shroud for that if you think you need that. Anything else, Davo?
That's it. Thanks, Joe. More information, Hyrel3D.com, Hyrel3D.net.